All right, today we are looking at factoring expressions. This builds off of what we were doing in our last lesson with the distributive property. What we're doing here is we're basically working backwards. So we are taking what was kind of distributed and then kind of finding what's going on and going backwards. This is a skill that you will use later on when you are solving equations sometimes, or even getting into solving quadratics in later grades. So factoring expressions is basically just separating an expression back into a product using the reverse of the distributive property. So our original expression here in simplest form is 2x plus 8. And what we look at for first is the greatest common factor for each term. So remember, terms are separated by that plus or minus sign. In this case, 2x and 8 can both be divided by 2. That would be their greatest common factor, which is why our 2 is outside the parentheses. And then we're kind of asking ourselves, what is left over, right? So what times 2 would give us 2x, and that's x. And then what times 2 would give us 8, and that would be 4. For those of you that had me in 6th grade math, another way we could look at this is we are factoring the terms using that cake strategy, 2x and 8, and we're factoring out, right? So then I would factor out that 2. So 2x kind of divided by 2 would give us x, and then 8 divided by 2 would give us 4. And then what we see here is what ends up being over here in our factored form. All right, now sometimes you cannot factor anything out. And if you cannot factor anything out, then the expression is considered prime. And what that means, right, what we were just talking about, is the terms don't share any factors. All right. And then the nice thing about this is that you can always check your work by distributing, so you can go backwards and then kind of go from there. A lot of ways it's like simplifying a fraction. All right, so if we look at 7x and plus 7, we can see that both of these terms have a 7 in them. So we're going to factor 7 out. And then 7 times what equals 7x? Well, that would be 1x or just x. And 7 times what equals 7 would be 1. And since there's that plus sign right here, we're going to keep that plus sign in the middle. All right, let's look at our next one. So we have 4k plus 20. So what's something that, since both terms don't have a k, what's something that 4 and 20 can both be divided by? In this case, it would be 4. And then we're left with k plus 5. All right, why don't you try the next two on your own? So go ahead and pause the video and try those on, and then you can check your work. 5m minus 15. We're going to factor out a 5. And then it's going to be m and 3. Now hopefully here you caught that there was a minus sign. So it would be a minus 3. Number 4, even though there's two variables, since the variables aren't the same, we can't factor those out. So 6 and 48 can both be divided by 6. And then once again, we have that minus sign. So this would be 6 times the quantity of r minus 8s. And then if you got 12w plus 24, we can factor out a 12. And then it would be w plus 2. And then hopefully on number 6, you notice that with 2 and 9, if you had the fraction 2/9, it can't be simplified. So since 2p and 9 don't share any common factors, this would be an example of one of those prime expressions. You can't do anything with it. It cannot be factored at all. So hope that helps. Just kind of looking at that. If you add something where you had the both same variable in both, you could definitely factor out as you're kind of going through.